Okay, here's a wild thought. What if we could treat energy not as a physical thing we have to ship and store, but as pure information? That's the radical idea behind a new technology called the Forerunner Stack. It's aiming to completely rewire our relationship with power, and today, we're going to break down exactly how it's supposed to work.
So this is the company's mission statement, and you got to admit, it's pretty ambitious. The phrases that really jump out are advanced physics and digital twin simulation. What they're saying is they want to merge the real physical world of energy with a perfectly mirrored virtual world to manage it with incredible precision. It's a huge claim. So how are they planning to pull it off? Well, let's start at the very foundation.
Every big idea needs a solid starting point, right? For the Forerunner Stack, that foundation is the actual hardware that generates the power. This is layer 1, the core reactor.
Now look at this slide. It's just one number, 95%. That is the claimed efficiency rating of their core reactor. And to give you some perspective, that's a monumental leap forward in energy generation. It means minimizing waste and maximizing every last drop of power we can get. But how is that even possible?
Well, the secret sauce is something they call next-gen electrolysis. Basically, by using this advanced proton exchange membrane, the reactor can split water into hydrogen and oxygen with almost no energy loss. This is the physical engine that powers the whole system, creating clean energy at that incredible 95% rate.
All right, let's move up to the next layer, because this is where things get really wild. Layer 2 is the digital conversion engine, and its job is to turn physical energy into digital information. Yep, from atoms to bits.
This is the game-changing idea at the heart of it all. What if you could store energy not in a giant physical battery, but on a server? What if you could send it not through a power line, but over the internet? I mean, think about it, like turning a gallon of water into a tiny zip file. You can store it, copy it, and email it anywhere in the world, instantly. That's the kind of revolution we're talking about here.
So here's their process, broken down into 3 steps. First, the electricity from that core reactor gets fed into some very specialized computer hardware. Second, that hardware performs what they call complex calculations. It's basically converting the energy's potential into a stable digital format. And the final output? Just pure binary data, ready to be stored or...
So we have the engine creating the power, and we have the translator turning it into data. But what's running the whole show? That brings us to layer 3, the intelligent control layer. This is the software brain that orchestrates the entire system.
This software brain is basically juggling 4 main jobs. It handles real-time balancing to keep the grid stable. It enables a decentralized mesh network for energy trading. It guarantees security with something called cyber immunity. And it uses predictive AI to stay one step ahead. Let's quickly look at each one. First up, real-time balancing. You know, power grids are incredibly fragile things. They need a constant, perfect balance between supply and demand. The Forerunner software can apparently react to tiny fluctuations in the grid in milliseconds, making adjustments almost instantly to keep everything stable and prevent blackouts.
Next is mesh networking. Now, instead of a top-down model where a big power company controls everything, this system allows individual nodes, think of a home or a business with a Forerunner stack, to trade energy directly with each other. It creates this decentralized, resilient, and maybe even a more democratic energy market.
Then we have security. So the old model on the left is reactive. You wait for a threat to appear, then you create a patch for it. Cyber immunity on the right is a totally different philosophy. It's proactive. It uses quantum-resistant encryption. It's designed from the ground up to be invulnerable, not just to today's cyber threats, but to the supercomputers of tomorrow. And finally, the AI. The system doesn't just react to what's happening now. It anticipates the future. Using machine learning, it crunches tons of data to accurately forecast energy demand and predict weather patterns, like how much sun a solar farm is going to get tomorrow. This lets it optimize everything before the energy is even needed. So let's pull all 3 of these layers back together. You have the physical engine, the digital translator, and the intelligent brain. When you combine them, you get a system that genuinely starts to treat energy as if it were just another piece of information. This table here lays it all out pretty clearly. Energy is created by the engine at the bottom. It gets converted into data by the translator in the middle, and it's all managed by the brain at the top. It's a single, fully integrated system, from atom to bit to decision. Which brings us to our final thought, the really big one. For all of human history, wealth and power have been tied to physical resources and the infrastructure to move them. But if energy can be stored and transported as easily and as globally as data on the internet, what does that actually mean for the global economy, for geopolitics, for society itself? It's a question worth thinking about.